Today, it may not be the most exciting episode, but we're going to do some package upgrades. Why do we need to do this? Well, there's two packages that we've been using, Zimp and zGUI. So Zimp is our kind of asset cooker, and zGUI is our UI, like our UI framework for our editor. Well, they're both packages that I work on and I've been continuing to update as the series has gone on. We're using some stuff that's out of date. So if you've been following the series, it may be reaching a point where you can't compile the code. And obviously I don't want that for you guys. So I will make sure we use the latest version of our packages and then fix up any API changes and make everything work again. So I'm not going to ramble too much longer. Let's just get into these changes. So the very first things we're going to do is actually just fetch everything. So the first thing we're going to do is fetch the latest version of zGUI in our Zephyr editor. There we go. And then we're going to do the same, but in runtime, we want the latest version of Zimp. So let's just grab that. And we should see that if we go to our build.zig.zon. Oh, actually, let's just, if it says path, that means you're using a local version. So just try that again. There you go. So URL and hash, so now that should be all good there. If we do the same thing here, we see we have a updated version of zGUI. That's perfect. So now let's get into all the changes we're going to need. So let's start by going into our Zephyr runtime, and we're going to go into mesh.zig. So one of the things that I basically added was that meshes right now, they can only have one kind of mesh or one sort of part. But now in Zimp, if we have a mesh that's loaded in from a GLTF file and it has multiple different submeshes, once we make these changes, those submeshes will be able to render because we weren't handling it properly. And very first change is now we're going to have multiple vertex arrays. And now load from zmesh is actually just going to be load part because it's going to be loading part of it. And it's going to change the type. So we'll actually have a const zimp formats zmesh and mesh part. And it's going to return a vertex array this time. Because now that we're storing an array of vertex arrays, every part kind of translates into that vertex array. So now this is also going to change. So now we're actually just going to return the val that we create. And these will be similar, except do self.vows val, and we'll draw each individual one. And I guess we should actually rename this to be vows. That's just a little bit of a better name. And then something similar with deinit. So for self.vows pointer vow, we'll do a vow.deinit. And we'll also need a self allocator free self.vows. So now we will store an allocator on here. And now the original load from zmesh, it'll now take an allocator, zmem allocator, and then a mesh, which is a zmesh. And now we'll return. So this is essentially the initial definition we had, but now we're adding an allocator. So now vows will need to allocate it, allocate however many parts we have. And so now let's get our ABBs, mesh parts 0 dot mesh min and max. And now that we have that, I'm just slowly gonna at some parts probably paste some code. So we don't need that, but now we're gonna go through the rest of them and try and first of all load it. So again, this is that function we have here. So we're gonna create the val for each of them. And now we'll just compare the mins and just constantly try and get the mins and maxes for the ABBs. And then when we return, we'll have vows equals vows, min max, allocator, and everything. Now let's head over to material, where this is just going to be a small one. Apply alpha mode. So now instead of source, it's actually going to be render state, because now that information is stored on it. And then if we actually go into this, we can have a better type. It's alpha mode. Okay, and now let's head over to source.zig. We're going to look for zimp.runtime. It's actually now called path, and it's going to be validate virtual. Now, the biggest change we have is in asset manager, because now things have changed. We actually have UIDs directly in Zimp now, so there will be no kind of asset. Instead, it'll just be Zimp and Zimp. And now we will want an asset ref, which is going to be a struct with a kind, with an asset kind, and an ID. And now we'd also get rid of this kind of shader program part for now because it doesn't actually kind of end up there. So we'll fix that up. And anywhere we have shader program, we'll be getting rid of for now. And again, that's kind of just how it is because also shader programs, instead of just being an asset ID, we're going to directly store the shader now. Shader program. So then you come down here, same thing here, pointer to a shader, and now shader IT. So now instead of key iterator, it's just going to be, oops, iterator. And now we get every key, and it'll actually be key pointer, and then key dot value pointer, dinit, and destroy the value pointer, and then you free the key pointer. And then we'll also look for shader program itself. And this one can go, it's kind of just cleaned up a bit. Load from zmesh. Remember, this now takes an allocator. Let's see, is it not there? Load from zmesh. There we go. And now we go find our vertex path. And again, this is one of the ones that was kind of changed in the API. We'll head down to new asset ID and go to where that's defined. And we see we don't have that anymore. It's because we have asset ID .v4 directly. And we will want one kind of helper function here. It's going to help us const 8 asset kind and asset type zimp runtime.detect type path, else return null, and then return asset kind dot from asset type asset type. So kind of just a translation layer for us. And then we see here it's kind of that inferred type kind that we have right there. And inside of normalize expected itself, we will have to update path. And then it's also that normalize virtual. And now this load is going to be to asset type. And that's because this now is going to be an asset kind. I know there's lots of changes, so just pause as you need, take your time. It's a lot of small things that just will end up making sense, hopefully by the time you look at it holistically, but yeah, it can be a little confusing. So now we can get rid of all of this and just do a try self.shader programs.put lookup key and shader directly. And now if we come up just a little bit up here, so .shader, it's going to be shader stage, and then here it's going to be actually just returning the shader because again we don't have these IDs now. And now if we keep going up, we see here there's another one, so it's actually going to be self.normalize expected. And this time we're doing the cook path and texture. So again, another one that just gets simplified, and it's going to be the same, essentially the same thing with these two vertex and fragment paths. So instead, self normalize expected, take the vertex path, and now we're saying it's a shader stage. So overall, things are just getting, I'd say, simplified. And self normalize expected. Now let's kind of time the fragment shader path and then shader stage. Okay. And there were a lot of changes there. So let's first just do a zig build check, make sure there's no glaring errors. Ah, yes. Okay. So we actually, the last thing we need to do is update our roots. So one, we'll just look for UUID here. And now all these will be a little bit different. So asset kind, zimp asset kind. Same with asset ID. Asset ref this time is actually coming from our asset manager dot asset ref, and now UUID is coming from zimp UUID. Okay, and now let's try that again. There we go. So now our check command built, and there still could be a mistake when it actually tries to run it, but let's move over to all the few upgrades that we need in our editor. So one thing that may seem confusing, but it'll make sense soon, is we're going to temporarily stop cooking our assets. And that's because in the very next episode, we're going to introduce project files. And that's going to be where we can actually point where we want to cook things from. Because right now it's hard coded. It's, in the source and output, but it's actually Zimp was also updated. So it depends on project files, which again, very soon, very next episode, be all about that. And we'll immediately bring back cooking assets. So you can still, if you want to go look into Zimp, you can still manually cook assets with Zimp CLI. But for now, we are going to get rid of it. I don't think we need anything else here. Okay, and just a few changes we are going to be making to our assets. And that's materials have changed a little bit. So this one I will just kind of paste in because it's be a little tedious. Yeah, and remember how we changed the render state? Well, that's coming from here, and then we can point directly to different textures. We can specify each param individually, and it's just a little bit cleaner. And like I said, like I'm constantly trying to make Zimp better. So this is just one of the ways to do that. So then we'll head over to our game scene, and things have moved a little bit. So meshes on monkey, and this kind of sets us up more for the next episode because again, we're going to stop cooking. So this won't be able to fully run, but we want it to compile. The goal of today is we make all our code compile because right now editor won't compile. And then next time, everything's going to be running by the end of next episode back to normal and in a much better way. Okay. And then we'll create a new file. So this is the one kind of bigger change to zGUI where we're going to need to capture input ourselves. So we'll just get UI, zGUI, and then I'll just put it in here. So again, this is very similar to kind of what already existed inside of zGUI itself, but it's kind of now we're just trying to move it into our kind of own ownership because it allows us to then properly just have a better abstraction. And again, it's just going to be accepts input and then we can translate it to how we want. And then again, there's not too much happening. And then we also need to be able to process scene events. So again, that's calling our app. So we're kind of just taking over the scene input. Now hopping over to main, we'll need that. So scene input, and this is exactly what we just did. Scene input. Now coming down here, we can see how it's doesn't exist anymore. So we'll just get rid of this and it'll be scene input dot scene input capture. And now when we look at UI frame, it's going to be a little bit different. So we'll still have runtime events as the second parameter. But now if we look in here, we'll want window size. So this is where we're actually taking control and being able to inject in input to UI size app.window.get window size, frame buffer size, very similar stuff to pixel size, and app window get frame buffer size, and then delta time equals app.time.delta time. Perfect. And now we actually do want our doc result. And then we'll come down right here. It's gonna be a little bit different. So now there's our UI. So this is actually a bug that existed today, where if you started to drag the panels around, it would move everything in the middle in our frame buffer. So then there's kind of input bleeding into each other. So this will just fix that. If we're dragging, we make sure we're not actually moving the main part. And then try scene input. Now we do the processing events, runtime events, viewport rect, UI state.input.mouse pause. Then we have our scene capture, and then UI owns mouse. So this is a big reason we needed this kind of abstraction. Oops. This is meant to be runtime events. Okay, and now we can see everything better. Let me actually clean up a few of these because I'm sure it's a little hard to see. There we go. That should be a bit better. Now we can see everything on the screen. And that's the big change. So now let's attempt to build it. Again, it won't probably run, but let's at least see if we have any compilers. Okay, so there is one thing in runtime we see here. So union field texture is index 2. So we come back up here. I think it's with the ordering. So texture is supposed to be number 2. So let's just move this around. That one is more of a strange one. Let's see. Okay, so submanager 190. So we want to get rid of that. Like I said, there's just lots of small things I'll need cleaning up. Okay, so we compiled. And now file not found, asset not found. This is expected right now. Like I said, things have changed a little bit. Things aren't properly cooked or built locally for us. And we're going to fix that all next episode. So I know it can be a little annoying not having a running version every single episode, but that's why I'm trying to put this midweek with as an extra upload, and then we'll get very soon, the next video I post will be the project files and making this all work together. And I hope you enjoyed the video. Again, it's not the most exciting thing, not the most flashy thing, but our code wasn't compiling at the start. Now it is, or I should say it wasn't compiling with the latest version of packages. So now it is. Now it should be easier to use. And yeah, it just, overall things are a bit cleaner. Again, it's always good to be at the latest version. We get the latest and greatest. Yeah, that's all I have. If you enjoyed the video, make sure to like, comment, subscribe. If you're excited for project files, make sure you give it a like. And yeah, that'll be coming in just a few days. So have a great day.